Our last task with radical functions will be to graph them. The most basic radical function would just be y equals the square root of x. So we can take a look at what would this basic graph look like. First step, as you graph any function, no matter what it is to just simply start getting some points. We always try 0, so let's go ahead and put 0 in. Square root of 0, 0. And if we do 1, square root of 1 is 1. Now, when we try 2, we get the square root of 2. Now, the square root of 2 approximates 1.414, but I really don't want to graph that, so I can just ignore that. I don't have to do 2. So I can choose to do other numbers, like 3, but if I do the square root of 3, again, I don't come out with a really nice number, so I'm going to ignore that. I'll do 4. Okay, the square root of 4 I do like because I get a nice even integer. 5, not so much. 6, 7, 8, but 9 works. 9 works nicely, as does 16. So now I've got a bunch of points. Let's go ahead and give this a shot. So as we're graphing this, we're going to want a number to make sure that we get the right ones on. So we're going to pick our x's and y's to make sense. I only need to get from 0 to 4 on my y, but I do need to get up to 16 on my x. So you can see that I made my intervals much larger on the y-axis than I did on the x-axis. So we have 0, 0, we have 1, 1, we have 4, 2, 9, 3, and last but not least, 16, 4. Okay, so you can see that this is not a straight line. This is a curve. If we continue off to the right and keep picking larger numbers, if you think about 25 or 36, we'll continue to go up. We'll go to 5 and 6. So we would assume that as we go to the right, we'll have continuation, an arrow. But we also need to check to see what happens to the left. So let's go ahead and go back and pick some more. This time, let's pick some negative numbers, like negative 1. And immediately we see that we have a problem, right? The square root of negative 1 is impossible. The square root of negative 2 is impossible, and so on. So you can't go to the left. There are no negative numbers at work. So when we draw this graph, we're going to draw it with a dot and not an arrow. So now again, my insistence on arrows all this time makes sense because not every equation does have an arrow. We're going to take a look at another radical function, but we've made a change. This time there's something other than the x inside the radical. So as we're going along, we normally start with just 0. But if I put 0 in, 0 plus 2 is 2. The square root of 2 is a number that I don't particularly love. So I don't need to do 0. This is one of those times where 0 doesn't really work all the time. I do need to find the most important point, and that most important point is that starting point, right? Where it can't go to the left anymore. So we have to think about it, right? Going to the left means that it stops someplace because beyond that you're taking the square root of a negative number. So what we need to do is we need to figure out what number would make the inside negative, or at least almost negative. So to find the domain, or the numbers that do work, that's what the domain is, the numbers at work, we take what's inside the radical, and we ask what would make it 0. Well, in this particular case, if x was negative 2, we would put negative 2 in. We will get the square root of 0, which is 0. Now, If we put anything lower than -2, like -3, we get something that does not work. We get the square root of -1. So there's nothing to the left of -2 that works. Therefore, our domain is any number that is greater than or equal to -2. This is our domain, the numbers that could work in this equation. We now start picking other numbers. So we need to pick numbers that are larger than -2, and we want to pick numbers that eventually get us to, hopefully, perfect squares. So if we try -1, -1 plus 2 is 1. The square root of 1 is 1. If we try -2, if we try 0, 0 plus 2, we don't like that. If we try 1, 1 plus 2, that's 3. We don't want to take the square root of 3. But if we try 2, we get 2 plus 2. And 2 plus 2 is 4. The square root of 4 is 2. We do like that. So we just need to keep going along, finding points that work. 3 is not going to be great. 4 is not going to be great. Right? We're going to look for numbers that are going to get us to perfect squares. In this case, 9. Right? So what would x have to be in order to get us to a perfect square of 9? 7. So 7 plus 2 is 9. Square root of 9 is 3. And now we're starting to get those numbers. Let's label and number the graph. Let's go ahead and graph the points that we do have. So we need to graph -2, 0. So we do have a point that's on the left side. We have -1, 1. Sorry, that point's pretty bad. We have 2, 2. And then we have 7, 3. We do get the right kind of curve. So it starts at -2, 0, and it will continue on to the right and above forever, but it is going to stop at -2, 0. Okay, time for the practice problem. So here's one. I've just added one more step. Y equals the square root of x minus 2. The x minus 2 is under the radical sign, but then we also have a -1, and that is not under the radical sign. So think about order of operations as you do this problem. Stop the video, practice it, do it, and then come right back. Okay, the best place to start for this one is going to be to figure out what I can and what I can't put into the radical sign. So again, anything that we put into the radical sign has to be bigger than or equal to 0, right? I can't put anything less than 0 under the radical sign as a final number. I can't take the square root of -1. So if I just set what's under the radical sign greater than or equal to 0 and then solve it, I know that I'm looking at all the numbers that are bigger than 2. And again, this is my domain, all the numbers that I'm allowed to put in. So I'm going to start with 2, and I'm not even going to look at any other x's that are below that. So we put in 2. 2 minus 2 is 0. Square root of 0 is 0. 0 minus 1 is -1. Okay, my first point. I can do 3. 3 minus 2 is 1. Square root of 1 is 1. 1 minus 1 is 0. If I try 4, I get 4 minus 2, and I get the square root of 2. Again, don't really love it, so I'm just going to skip 4. I'm going to skip 5. Let's try 6. So the square root of 6 minus 2. 6 minus 2 is 4. Square root of 4 is 2. 2 minus 1 is 1. And now we're looking for what would make it 9. So that's 11. 11 minus 2 is 9. Square root of 9 is 3. Minus 1. And then we're looking for the numbers that maybe make it 16. That's the next perfect square. So what would make this thing underneath the radical 16? That would be 18. So you can see how you can sort of think about what it would be to get to where you want to go. Square root of 18 minus 2 is square root of 16. That's 4. 4 minus 1 is 3. So now I've got plenty of points. Let's graph these and see what happens. Okay, so I've got my 5 points. start graphing these. 2, -1, 3, 0, 6, 1. The trick is sort of getting everything to fit, but not making it so cramped and crowded that you can't actually put points on. And sometimes that can be a little tricky with trying to decide how spread out and how crowded you can. Okay, so we start at 2, -1. That's going to be our starting point. We're not going to put an arrow there, but we are going to put an arrow going to the right. So again, this part right here, this ending point, shows us that the domain starts at 2. And we don't need to go any farther to the left than that.